Well, hello guys, here Mr. G with another video. This time we're going to be answering a question on bonding mostly. This is for the grade 11s, but this is also applicable for grade 10. This was a question 3 from June 2013 at the Northern Cape province, and we are going to answer the question now. But before that, please subscribe for the channel so you can get all the notifications and videos I post on regular basis. This question says boron bonds with halogens to form boron halide. Draw the Lewis structure for boron fluoride molecule. Alright, and we are going to be drawing that one there. Now, to answer this, the first thing you need to know is the valence electron for boron and the valence electron for fluorine. Okay, boron have 3 valence electron. Let's write it here, 3 valence, and fluorine has 7. Right, that is the first important thing you need to know for boron and fluorine. So if you represent boron, then it will be 1, 2, and 3. That will give you the valence electron of fluorine, and then of boron. And fluorine, you have 1, 2, 3, 4, 5, 6, and 7. You can see that you have 1 unpaired electron in fluorine, but you have 2 of them. So all you have to do, so you have 3 of them. So you have to share each of these valence electron of boron with 1 of fluorine. Okay, so we're going to do that one real fast. So you are going to represent boron in the center with the 3 valence electron, and then you are going to write the other valence of the unpaired electron of fluorine. Here is 1 fluorine, there is another fluorine, and there is the other fluorine. So this is that boron fluoride. That is the molecule we represent, and this is the Lewis dot diagram. Or you can now represent it with a line, in which each line represents 1 bond. So boron with 3 lines with each fluorines in each side, but each fluorine you must represent the valence or the lone pair there like it is now. So this one is boron fluoride. Okay, so this is the Lewis dot diagram. It can be used lines for the bonding now here. So that is the answer for question 3.1. Question 3.2. Write down the name of the molecular shape of boron fluoride. Guys, if you go here to the answers, you can look at this one, and this one is quite simple. This one is a trigonal planar molecule. This is a trigonal planar molecule. It's quite simple, guys. Let's go to this one is 3.2. Let's go to question 3.3. The table below gives electronegativities values of different elements, and they give you the elements and the electronegativity. Define the term electronegativity, and this is a term for grade 10, guys. Okay, so what is electronegativity? It's the measure of an ability of an atom within a molecule to attract the bonding pair. So it's the strength with which an atom is pulling the bonding pair. The higher the electronegativity, the stronger they're going to pull the bonding pair. Okay, so now question 3.3.2. What can we say about the electronegativity of the element as one move across a period? Now this one is a trend, guys. You have to learn. And you need to know that the electronegativity in a period or across a period from left to right will increase. That one is important. Please, it's going to be asked in the exam, or it can be asked in the exam. Use electronegativity values provided in the table above to determine the polarity of the bond between boron and fluorine. We're working with boron and fluorine there. So here is boron. There is boron. Let's mark it. And fluorine is there. Okay, so to do that question, the first thing you have to do is to calculate the difference in electronegativity between fluorine and boron, and this one will be equal to 4 minus 2. When you calculate that one, you get 2. Okay, now for this one, what do you have to remember? You need to remember that the difference in electronegativity will tell you the polarity of the covalent bonding. Okay, so if the difference of electronegativity is equal to 0, then the bonding is non-polar. This one is just recalling. Okay, if the bonding is between 0, obviously it cannot be 0, between 0, 1 and 1, then this one is weak polar. We're talking about the bonds. Alright, if the bonding is, or the difference in electronegativity is between 1, 1 and 2, then it's a strong polar. And if it's greater than 2.1, then it's ionic. Now this little table here, you need it because you will be asked about the polarity of bond for sure in the exam. So there you can see what happened. Now here we are in 2, which is in this range here, so it's a strong polar bonding. So all you have to say, they say use the electronegativity value provided to determine. We did calculate here, so it is going to be strong polar. That is the answer for question 3.3.3. So the answer is strong polar. Using the difference electronegativity state whether the bond between boron and fluorine will be covalent or ionic. It is covalent. You can see that the calculation, guys, it is here. Okay, so the bonding will be covalent. I'm going to just select it here. It will be covalent. What is the overall polarity of the BF3 molecule? Write down only polar or non-polar. There is a video of this one. I'm going to leave the link that can help you to understand this and explain your answer in question 3.4. Let's answer both questions. Here is the shape. Now, know the following. This molecule here, fluorine will be pulling stronger boron. The bonding will be pulling stronger. So fluorine will be slightly more negative than boron. So if you can see here, fluorine will be negative all the way around, while boron in the center will be positive. So this molecule, guys, is a non-polar molecule. There is not two poles. Now, how do we explain this one? That one is the tricky part, the 3.5. How do we explain this one here? Okay, the first thing you have to say is that each of the bonds in the boron trifluoride molecule is polar. That is important. That is the first statement you have to say. Okay, and then you have to say that the boron trifluoride molecule has a symmetrical trigonal planar shape. But this word symmetrical is important, and that's a non-polar molecule. Guys, this one is all for this question. It's a quite simple question, and in the grade 11 for this unit examination there is a lot of mark on bonding. I hope it helped. If it helped, please subscribe for the channel, thumb up. I'll see you next time. Mr. G here.